lot of talk about the dark side of the moon, but NASA has just announced an amazing discovery on the sunlit side.
We're never going to stop exploring the unknown in air and space.
The moon, our constant celestial companion, has long been a source of fascination and mystery. But in recent years, something strange and enigmatic has been unfolding on its surface, raising eyebrows among astronomers, space agencies, and enthusiasts alike. From failed lunar missions to peculiar lunar phenomena, the moon has been at the center of an intriguing cosmic enigma. We'll delve into the realm of lunar mysteries and explore why something weird is happening on the moon. This is Reveal the Mystery. If you're curious to learn mysteries of the world, space, and beyond, consider subscribing. Join us as we delve into the realm of lunar mysteries and explore why something weird is happening on the moon. In 1966, the Soviet Union's Lunar 9 mission achieved a significant milestone by becoming the first spacecraft to reach the moon's surface and execute a gentle landing. Before this, our lunar exploration efforts involved essentially throwing objects towards the moon and hoping they'd impact and transmit data. The Soviets, pioneers in this early lunar mission, accomplished another noteworthy feat in 1959 when their Lunar 2 spacecraft became the first human-made object to impact the moon or any celestial body beyond Earth. Fast forward to August 2023, Russia made another attempt at a soft moon landing with Lunar 25, but this mission ended in failure, resulting in a crash that added yet another crater and human-made debris on the lunar surface. It may seem like a surprising decline in moon landing capabilities given the technological advancements one might expect over time. However, it's essential to note that this challenge isn't unique to Russia. Other nations have also faced lunar landing setbacks. For instance, a Japanese company called iSpace attempted a lunar landing in 2023, but it failed. Additionally, India's Chandrayaan-2 mission also experienced a landing failure a couple of years before that. This raises the question, why is landing on the moon so challenging, especially in an era where technology has advanced significantly? Something intriguing and perhaps lesser known is the moon's peculiar and uneven gravitational force. While Earth maintains a consistent gravitational pull all around, ensuring an even attraction to its core, no matter where you are situated, the moon presents a different scenario. Gravity on the moon diminishes smoothly and predictably as you ascend from the surface, yet its gravitational field is uneven. Scientists have long observed that certain lunar regions experience a stronger gravitational force compared to others, leading to what could be described as a lumpy gravitational landscape around its periphery. Particularly noteworthy are the unexpectedly robust gravitational fields that often coincide with a handful of impact basins. These anomalies suggest that the moon's gravity is influenced by the concentration of excess mass resulting from substantial asteroid impacts. In 2019, scientists confirmed the existence of an enigmatic mass beneath the moon's south pole. Although its nature remains uncertain, estimates place this excess mass at around 2 quadrillion tons. While it's tempting to speculate about extraterrestrial origins, more plausible explanations revolve around its location under the South Pole Aitken Basin, an immense, oval-shaped impact crater on the moon's far side, measuring 2,000 kilometers in width and several kilometers in depth. This basin formed roughly 4 billion years ago due to a massive lunar collision. As one gazes at the moon, it becomes evident that it has weathered numerous substantial impacts throughout its history, resulting in the scattered and unpredictable gravitational forces that can have intriguing implications for spacecraft attempting lunar landings. Though this factor isn't the sole challenge in landing on the moon, it certainly adds an intriguing dimension to consider. When delving into the annals of history, a striking observation emerges. A significant number of endeavors aimed at lunar landings have culminated in disappointment. Such outcomes were hardly astonishing during the early attempts in the late 1950s and early 1960s, when expectations were relatively modest. Even as NASA transitioned to its Surveyor program in 1966, a series of robotic moon landings that laid the groundwork for the Apollo missions, the success rate left much to be desired. Among the 7 Surveyor missions, one lost control mid-course, culminating in a crash landing on the moon, while another mission lost radio contact with Earth a mere 2 minutes before the scheduled landing, shrouding its fate in uncertainty. The Apollo missions, particularly Apollo 11, marked a turning point, with human landings on the moon being flawless. This success is rooted in a fundamental difference. Humans can troubleshoot problems on the fly, whereas robots lack this capacity, or at least they did at that time. The critical moment during the Apollo 11 moon landing would have ended in failure were it not for the remarkable piloting skills of Neil Armstrong. As the lunar module, known as the Eagle, deviated from its intended course and the computer guidance system failed to adapt to unexpected variables, Armstrong resorted to manual control, landing on the moon with only seconds of rocket fuel to spare. Clearly, not every lunar mission can boast the presence of a seasoned Navy pilot like Armstrong to address in-the-moment issues. For autonomous robotic missions, every aspect of the operation must proceed flawlessly according to plan. Otherwise, failure looms as the most likely outcome. The moon is proximate in cosmic terms, yet its distance necessitates precision in landing, which poses a significant challenge. Remote control isn't a feasible option because the average round-trip communication delay is approximately 2.5 seconds, a time frame insufficient for a successful landing. This might seem perplexing, especially considering NASA's successful track record of landing on Mars in recent decades, despite Mars being significantly farther away than the Moon. A crucial distinction lies in the presence of an atmosphere. Mars, though having a thin atmosphere compared to Earth, offers sufficient density to deploy parachutes for deceleration. On Mars, a parachute alone doesn't ensure a soft touchdown, but it can reduce spacecraft velocity, affording controlled descent. For the final touchdown, simple airbags cushion the impact of a lighter payload. In contrast, the Moon, devoid of an atmosphere, precludes the use of such technologies. Lunar landings require a comprehensive re-evaluation of conventional landing methods due to the absence of an atmosphere. The Moon requires a rather complex way of landing called fully propulsive landing. This means landing on the Moon using rockets, which can be quite challenging. Even though SpaceX's Falcon 9 rocket makes rocket-powered landings look easy on Earth, landing on the Moon is harder. The Falcon 9 relies on Earth's atmosphere and special fins to control its descent, but the Moon doesn't have an atmosphere. So, lunar landers must use carefully timed rocket burns to slow down from the high speed they have in space to a complete stop on the Moon's surface. This is quite a tough task. Also, consider that many of these modern Moon missions aim to land at the Moon's south pole. This region is crucial for future human exploration because it likely holds a lot of water ice, which is important for drinking, breathing, since it contains oxygen, and as a fuel source, since it has hydrogen. To reach the South Pole, you need to follow a more complex flight path, making the mission three-dimensional. This is different from the earlier missions that aimed for easier two-dimensional landings near the Moon's equator. While it may seem challenging, it's important to remember that failures are a natural part of learning and improving. Just like NASA had many failures before succeeding in landing on the Moon, modern missions are also learning from their mistakes. For example, India's Chandrayaan-2 mission faced difficulties but learned from them to succeed with Chandrayaan-3. Mistakes are opportunities to get better, and they're a part of space exploration, just as they are in other areas of life.